Hello. In this recording we start considering transport layer, the content of chapter 3 of our course book. In this recording we will introduce the transport layer services. We consider the principles of multiplexing and demultiplexing in the AND systems and go into some details of the user datagram protocol. Remember our discussion from previous recordings about the content of the communication stack in the internet architecture. There we have application layer, which implements the communication content that we as humans interpret as either services or games or textual audiovisual content. The applications are processes that run inside end systems. So in order to communicate between two applications, you need to address the machines, the client and server machines that communicate between each other. This functionality is implemented by the network layer over here. So the lower two layers are responsible for communicating pieces of information locally between local devices, for example, between your laptop computer and the first router, or between ADSL modem and the first router to the internet at the internet service provider side. In this recording, we focus, or in this theme in general, we focus on the content of the transport layer. Why do we need a transport layer? Transport layer helps us to find the content within the machine. So if network layer establishes a communication channel between two computers, transport layer takes care of communicating between two application processes. That is why transport layer protocols run inside the AND systems. So the sending side of the transport protocol breaks the application layer messages into pieces which we call segments and passes them down to the network layer. At the receiver side, the transport protocol receives the segments from the network layer, reassembles segments into messages, and passes it to the application layer. This is the functionality of transport layer protocols. And in the internet, we have two transport layer protocols: transmission control protocol, TCP, and user datagram protocol, UDP. Essentially, the transport layer protocols play a role of multiplexer, demultiplexer of information within the AND system. So here, by multiplexing, we understand a process at a sending host which gathers data from multiple sockets, enveloping the data within with the header, and this header is later used for demultiplexing. The demultiplexing process, at the same time, runs at the receiving host, and it is about delivering the received messages, segments, to a correct socket. In order to enable the multiplexing, demultiplexing processes, we need to supply two very important pieces of control information with every data segment that we send out to the network. These control information are source ports, source and destination ports. This schematic over here shows the common parts of the transport layer segments, common both to TCP and UDP protocols. The protocols are different in many ways. So you know that UDP protocol is a connectionless and unreliable transmission protocol. Transmission Control Protocol, TCP, on the other hand, is connection-oriented and a reliable transmission protocol. This diagram shows the functionality of the demultiplexing process in the connectionless case, so in the case of user datagram protocol. The server machine with its stack shown here in the middle, when it wants to implement a UDP based application, it opens a socket for incoming data in this way, shown here. So it just opens a socket on a selected port number. The client machines, those at the borders of this diagram, when they create a socket, they need to specify the destination address for the server and the destination port number. The connectionless case essentially means that the server doesn't differentiate packets based on the source IP address. This means that IP datagrams with different source IP addresses and possibly different source ports, they would be directed at the server side to the same socket as it is demonstrated in this diagram. When the server receives a UDP segment, it first checks the destination port number, so these numbers over here, and that's it. It directs these different diagrams to the same socket which is registered on this port number. The main difference with the connection-oriented demultiplexing comes with the identification of a connection by four tuple shown here. So the connection is identified by, first of all, source port, the port at the client machine, the destination port, the port at the server machine, the source IP address, and the destination IP address. So if we are talking about the incoming packet from a client to the server. This means that the server machine opens individual sockets for each individual connection identified by this four tuple. If we take a web server as an example of a TCP-based application, then these different sockets are implemented as threads. So we have a single process implementing the server, and this process spawns the threads, the parallel processes, one for each incoming client. Recall that in the Internet architecture we have two transport layer protocols, UDP and TCP. Why do we have two different protocols? Well, it is simple. We have different applications which place different requirements on the way how the data is delivered through the network. Some applications, like web, for example, they require obviously in-order delivery and delivery of all information that was sent from the server to the client. Otherwise, the information that we get out of this communication would be unintelligent. On the other hand, we have such applications as, for example, streaming multimedia, a voice over IP. So in these applications, we as humans may tolerate certain losses of information. So we may comprehend voice, human voice, even if some parts of the data is missing. That is why we need a simpler protocol without all this overhead of establishing a connection and controlling the transmission of different pieces of data. So we need just the functionality of sending a piece of information from host A to host B. And this is implemented by the user datagram protocol, which format is shown here on this slide. There is really not much more to say about UDP protocol. It is very simple. Probably what we need to know is the primitive mechanism to check the correctness of the received data. This is used by application to decide whether the received packet contains errors or not. So the error checking in the user datagram protocol is done by using the checksum field shown here. What the sender does, it treat the segment content, the content of the entire segment, as a sequence of 16-bit integers. And to compute the checksum, the sender computes a so-called one's complement sum of the segment contents. And this I will show you on the next slide. At the receiver side, the process is reversed. So again, the receiver splits the content of the received segments into 16-bit chunks and computes the checksum in the same manner as the sender host did, and verifies whether the result of the computation equals to the checksum value, to the value indicated in the checksum field of the UDP header. This slide shows a simple example of a so-called one complement sum. So we have two 16-bit integers to add, so shown here and here. So, and we perform binary addition. So 1 plus 0 is 1, 0 plus 1 is 1, 1 plus 1 is 0, 1. So we carry on the bit in the binary addition. All right. So if we continue this way, computing the sum until for all the bit positions of the 16-bit integers, then we might have a carry-on bit. This bit we need to wrap around and add it to the resulting 16-bit integer. So we add it in exactly the same way as we did before. So in this case, so we add 1 to 1. This becomes 0, and I carry on 1 to the next bit position. So and again, we add 1 and 1. We got 0, and I carry on 1. So all the rest of the sequence remains the same because we do not have any more carry-on bits. What we do then, we invert the sequence. So we take the complement. So we convert all ones into zeros and vice versa, and this becomes our checksum. That's it. All right, that's it for the basics of the transport layer services and the functionality of the UDP protocol. Next time we start considering the functionality of reliable data transfer. Bye bye.